Alright, as we're waiting for people to come on in, just a heads up, webcam's being weird for whatever reason today. It was not giving me any kind of audio before with my microphone, and now it's doing that, but now it's not giving me video, so I'm not really sure what's going on. But as long as you can hear me, that's really the important part. So, what we went over last time was numbers and operators, and we said that really what we're doing in this course is we're putting numbers together with operations, and eventually we're going to get to the point where we're kind of missing some parts, and we need to figure out what goes there, or what can go there, or what happens if we put a particular thing in that empty space. And that's going to be the real meat of algebra for this class. Now, in order for us to be able to do any of that kind of stuff later on down the line, we need to practice our order of operations. Okay? So, again, order of operations tells us exactly what order to do operations in. So, if we have add, subtract, multiply, divide, powers, parentheses, things like that, what do we do first, what do we do second, what do we do third, so on and so forth. So let's say that I have something like 4 times 2 minus 1 to the second power, I don't know, plus 5. Okay, then say the whole thing is over 2. Okay, so again, order of operations, we need to do parentheses first, then exponents, then multiply and divide, and then add and subtract. And again, this is the one you've probably seen before, PEMDAS, but we also have GEMS, which is grouping symbols, then exponentation, multiply, divide, in the same step, and then subtract and add in the same step. Okay, so if we look at our order of operations, it doesn't matter which one we look at, the first thing we need to do is parentheses or grouping symbols. So we do indeed have a set of parentheses here, and this set of parentheses has one thing to do in it, 2 minus 1. So we'll go ahead and do that. 2 minus 1, of course, is 1. And again, like I said last time, once we do one step, we want to rewrite our expression with our new values. Again, an expression is just a group of numbers with operations. Okay. So I have my new values down here, and I have 4 times, in parentheses, 1 squared plus 5 all over 2. So now what I want to do is I want to, let's see, exponents. I want to take my exponents. Now notice that I've left this 1 in parentheses. Technically for this one I didn't have to do that, but I'm going to keep it in parentheses because there are still things happening to this value in parentheses. First of all, like we're about to do, we have an exponent on them. So when you have an exponent on the outside of these parentheses, it means that there's still something happening to this value in parentheses. We're taking it to the power. The other thing that's happening here is that we are multiplying it by 4. That 4 directly on the outside of these parentheses is multiplying this value inside of it. So if you have anything that's still happening to the value inside of your parentheses, it's a good idea to just keep those parentheses there. But again, we need to do exponents, so 1 squared is 1. So now we have 4 times 1 in parentheses plus 5 all over 2. Okay, so next we can multiply, divide. Now, Jim's is all one step. Do multiply and divide all in one step. Let's see what happens here. If we multiply 4 times 1, we get 4. But can we actually divide this? No. Before we're able to divide with this fraction, we need to know the value of both the top and the bottom, and that is the complete value. So while we can do multiply and divide in the same step, if it was something like 4 times 3 divided by 2, I don't know, then yeah, we would be able to do multiply and divide in the same step. But we have a fraction here, and this is telling us basically it's like another set of parentheses. Both of the top and bottom values have an imaginary set of parentheses around them, you can say, because we need to figure out what the actual value of that top is and what the value of the bottom is. Then, once we find those values, we can divide. So 4 plus 5 is going to give us 9. Over 2. And at this point, again, you could make this into a decimal, 9 divided by 2. Or you could leave it like this, and honestly, I would rather you leave it like this for most of the problems that I'll give you. Okay. So let's try some more. Let me just pull up my notes here. Okay. So like I've been saying, expressions are just where we have values being combined with some kind of operation, whether it be add, subtract, multiply, divide, exponents, or roots. Okay? Now, what if we have something like, 2x plus 3? Well, this is still an expression. Now, what we've been doing with expressions so far is we've been going ahead and going through them and finding a perfect value, something that absolutely represents what we had before. Okay, the overall total value. This, we're not able to get a value out of it. It has some kind of value behind it. But the value that it has behind it, this is as far as we can get with it. We can't actually multiply 2 and x because we don't know what x is. We can't add 3 to that because, again, we don't know what x is. So without knowing what the value of x is, this is as far as we can get to the actual value of this expression. Now sometimes this is fine, sometimes this is what you want. We'll talk more about that later on in the semester. But other times we're going to sort of know what we want to use for x, or y, or z, or whatever variable we might have. So sometimes we know what we want to use for x. Sometimes we can plug in whatever we want for x, but let's just say that for this one we want to plug in x is equal to 4. Okay? Now, we can go ahead and replace x with 4, but what I want you to remember to do, and this is extremely important, is anytime that you replace this variable with this value, you want to replace it using parentheses. Okay, so we're going to open up a set of parentheses there where x is. I'm going to stick the 4 into those parentheses. Why am I doing this? It's because it preserves our operations. You can imagine that if I hadn't put parentheses in there and just put 4, well, it's easy to confuse that for 24, isn't it? So it comes back to the, we don't want people to get lost or confused when they're doing these problems. So parentheses is something that helps here. I'll show you another example in just a moment after we do this. But again, what this does for us is it makes sure that we are still multiplying 2 and 4. All right, well, what do we get if we multiply those? 2 times 4, that's 8. We've gotten a single value out of that. We've done a step, so we want to rewrite with the new values. Now we add, it's the only thing left for us to do. So 8 plus 3, that's 11. And so what we can say about this is if we use 4 for x, we get 11 now. Again, this becomes very useful to us when we start talking about things like functions, which we'll get to later on in the semester. Okay, so let's see another case. Now before we get into that example, remember that last time I asked you if there's a real big difference between this and this. So parentheses versus no parentheses. And indeed, there is a very big difference. So here, this is a quantity squared. The whole thing in parentheses is being squared. So not just the 2, but also the negative along with it. So what this really looks like if we were to expand it out, now I don't ask you to do this on assignments, I'm just showing you what it looks like if we were to make this a little bit larger, zoom into it a little bit. It would be like negative 2 times negative 2, because again, if that negative is on the inside of those parentheses, that means that it is being included in that square. So, we have negative 2 times negative 2. 2 times 2 is 4. Negative times a negative is a positive. So this comes out to be positive 4. Over here, we don't have parentheses. So the question then is, what is this square actually acting on? What is it actually affecting? Okay, Well, a power like this only affects the thing directly next to it. So like over here, this square is affecting the parentheses. And so since the parentheses are kind of trapping this -2 in there, it affects the entire thing. Here, that square is only next to the 2. The negative is not really a part of that. Again, if we were to zoom into this and expand it, what this really looks like is -1 times 2 squared. Which, of course, we can expand again to say -1 times 2 times 2. Since 2 squared is 2 times 2. Okay, so what does this give us? Well, 2 times 2 is 4, and then 4 times -1 is -4. So yes, indeed, these two things mean something very different. One will give you a negative answer, one will give you a positive answer. So this is something you always need to keep in mind, especially when you're dealing with even number powers. Even number powers have this weird phenomena here where you get a positive here if you have parentheses or a negative here if you don't have parentheses. Things like a third power or cube, you don't really have to worry about it because if we think about that one, -2 quantity cubed versus -2 cubed. If we were to expand that out, this would be -2 times -2 times -2. So -2 times -2 again is +4. Then times another -2, that is -8. Then here, we have -1 times 2 times 2 times 2. 2 times 2 times 2 is 8, times the -1 is still -8. So when you're working with powers like this, make sure that one, you pay attention to whether we have parentheses around that negative or not, and two, really think about what the power's saying. Okay, what does this mean we're actually multiplying? Are we multiplying, like here, -2 times -2? Are we multiplying -2 times -2 times -2? Think about it. Take a moment and think about it. Okay, but where was I going with this? So let's take a look at this. Let's have x squared minus 4x plus 2. Okay, so what we did last time is we plugged a number in for our variable. And we said that we need to use parentheses if we want to do that. So let's say that I'm going to plug in -1 for x. So x equals -1. Again, I want to make sure that I use parentheses when I plug that -1 in. So everywhere that I have an x, I'm going to open up a set of parentheses. Okay, and then I can put that -1 into each of these parentheses. Okay, so again, parentheses are really important for when we're sticking these values into our variables. You can imagine that if I didn't have parentheses, if I hadn't used parentheses, which would be the wrong thing to do, but this would look like -1 squared minus 4 minus 1 plus 2. So two things have gone wrong here. First of all, x is supposed to be squared. The entire x is supposed to be squared, which here, in the correct way with the parentheses, the negative and the 1 are both being squared because they're in parentheses. Here, only the 1 is being squared, not the negative. So this is the first place where we're going to have a problem since we didn't use parentheses. Again, here we use parentheses. So before we had 4 times x. This is still 4 times whatever x was, which is negative 1. So we're still multiplying here. 4 times negative 1. Here, we're no longer multiplying. We have 4 minus 1. We've changed what we were doing. We can't do that. We have whatever we were doing before, we need to continue to do down here. So without parentheses, this changes from multiply to minus. No, we can't do that. That's not allowed. Okay, so this is why parentheses are so important for when we plug a value in for a variable. They make sure that we have the same operations that we had before. Again, they preserve our operations. So let's go ahead and see what we get with this one. Of course, PEMDAS or GEMS, whichever one you want to use, but we're going to go through grouping symbols first, or parentheses. Now, inside of these parentheses, we have negative 1. So do we really have anything we can do inside of the parentheses? No, it's just a single value. Again, the reason we have the parentheses here is to preserve our operations because other things are happening to them on the outside. So there's nothing to do on the inside of those parentheses. We can move on to the next step, exponentation. All right, I do see an exponent. I've got square there. And let's see, so it's negative 1 in parentheses squared. So remember that negative is going to get squared as well. So negative 1 times negative 1 gives us positive 1 because a negative times a negative is a positive. Now there's nothing else acting on that set of parentheses. There's nothing else is multiplying by it. We don't have another power. We don't have anything going on the outside of these parentheses. So I don't need to have those parentheses anymore. Could you keep them just to be safe? Yeah, you can keep them. That's fine. You can keep your parentheses all the way down until you get your answer. But I'm going to go ahead and take them off here. And of course, we've done one step, so we're going to rewrite our expression with our new values. Okay, so we've done exponents. Now we can multiply and divide. Well, I only see multiply. So I've got negative 4 times negative 1 here. So negative 4 times negative 1, that's going to give me positive 4. And again, I need to rewrite with my new values. Okay, now we had 1 minus 4 here before, but it's now positive, so this needs to be plus. So we need to change that sign. 2 just going to drop down, and now we have nothing but addition, so we can go ahead and finish this up. 1 plus 4 plus 2 is going to give us 7. There we go. Okay. So, one more time. Expressions. Expressions are numbers put together with operations. That's basically all it is. They have some kind of value behind them, and typically we're able to find that value by using our order of operations and simplifying the expression. That's actually what we've been doing this whole time. Going through those operations and doing them one by one until we get down to no more operations that we can do, that's simplifying. Okay, now for not expressions but equations. So what is the difference between an expression and an equation? Okay, well, if I put something down here like x plus 3, this is an expression. It has a value behind it. I can't find the value right now because I don't know what the value for x is. So I'm going to have to just kind of leave it like that for now. But if I were to add this to it, this is now no longer just an expression. This is an equation. So what is the deal with an equation? Well, an equation is really two expressions. So I've got x plus 3 and I've got 6 here. It's a single value. But really, I can have an expression on each side of this equal sign. And what the equal sign does is it compares the values on each side. In particular, an equal sign, an equation, is looking to say that both of those values are exactly equal. They are the same. Okay? So this is saying x plus 3 is the same as 6. They should have the same value. Okay, so what would we need to do to make this equal to 6? What would x have to be? Well, this one is pretty simple. We can just say, oh, well, I know. 3 plus 3 is 6. Yeah. Now, are we going to have problems like this where we can just guess what x is? No. Unfortunately, we're going to have college level applications here, so college level equations. But I'm just trying to show you that, yeah, an equation is trying to say that both sides are the same. They have the same value. So 3 plus 3 is the same thing as saying 6. So what about something slightly more complicated? Only slightly more complicated, though. How about 2x plus 7 equals, let's say 13. Okay, again, only slightly more complicated. Okay. So if you're, mildly astute, you might be able to say, okay, well, I can say x has to be something. You might know what x has to be. But this one is a little bit harder to just kind of look at and say, I know what that is. You might start to say, oh, well, so x is multiplied by 2, so it has to be something even there, and then plus 7, so 13 minus 7, and then already you're starting to solve this equation. Okay, so what I mean by solve is we get x by itself. We isolate x so that it is the only value on one side. After all, remember, what an equal sign does is it says that whatever's on this side is the same as whatever's on this side. So if we can get just x by itself on one of these sides, then the equal sign will be able to tell us that whatever's on the other side is what x is equal to. It's the same as x. But how do we do that? Well, a little bit of math trickery. We say that the equal sign holds balance. It balances both sides. Both sides are the same. So if we want to get x by itself, we can get rid of other numbers, but with a little bit of trickery. We can subtract this 7. So plus 7 and minus 7, well, plus 7 minus 7 cancel. They're opposites. But we can't just, willy-nilly throw whatever we want into this. We need to make sure that it's still balanced. So whatever we do to this side, we're also going to need to do the same thing to this side. And that makes it balanced. So that makes sure that, okay, if we took the 7 over here, we took it over here as well, this is still the same on both sides. The equal sign is still able to tell us that, yeah, this is the same on both sides. So again, positive 7 minus 7 are opposites. They cancel, leaving us with 2x on this side. Then equals, let's see, 13 minus 7, that's 6. Okay. So again, what we want to do here is we want to get x by itself. We want it to be completely alone so that the equal sign can tell us what it is equal to. So we have 2 times x here equals 6. Again, you can probably say, oh, well, I know what that is. If it's 2 times x to get 6, well, what do you multiply 2 by to get 6? Well, you multiply it by 3. Okay? Well, let's continue on with this theme of solving, getting x by itself. So we want to get x away from all the other numbers. We want to cancel out anything that isn't an x. So you might be tempted to say, okay, well, it's minus 2 now. Can't do that. We were able to subtract 7 before because we were adding 7. We were doing the opposite. So this was 2x plus 7. We did minus 7 because that's the opposite of plus 7. We have to do the opposite of what this 2 is doing. And it isn't adding, it isn't subtracting, it's multiplying by that x. So if we want to get rid of this 2, again, we need to do the opposite of whatever it's doing right now. If it's multiplying right now, the opposite would be dividing. Okay, so again, opposites, 2 times x, divide by 2, those are opposites. They cancel, leaving us with x. And then 6 divided by 2 is 3. And now our equation reads x equals 3. Again, that equal sign says that whatever's on one side is the same as the other side. They have the same value. So x has the value 3. Okay. So I think that will do it for today. Order of operations is extremely important. You will see it for the entire rest of the semester. We will use it for the rest of the semester, and you will use it for the rest of your math career. Solving equations, this basic, canceling things out, finding x. We're going to see that for the rest of algebra for sure. So these are probably the 2 most important concepts to get down. So I'll say this. First of all, I hope you paid attention to this lecture. But if you have any questions, if you would like any extra help, please let me know. Email me. Okay? Because I want to make sure that everybody gets these concepts down right now. Because if we don't get them right now, we're going to have a lot of problems later on since we're using this for the entire rest of the semester. Okay? So, once again, if you have any questions, need any help, maybe you just want extra examples, just email me, let me know. But I will see y'all on Monday. Let's see, what is the date for Monday? That is the 18th. Okay, so next week is again going to be 100% online, and then the week after that we will be back to face to face. So I'll see y'all on Monday, and I hope you have a good day. Oh, thank you. Sorry, there's no class on Monday. I had forgotten. So I guess I'll see you Wednesday. Wow, holiday already. All right, so I'll see y'all Wednesday.